Warahmatullahi Ta'ala Wabarakatuh. And hi, I'm Dr. Rohana. We discuss with you about Chapter 1 Basic Semiconductors. And in this video, we're going to discuss about N-type and P-type semiconductors. For overview of the subtopic, N-type and P-type of the semiconductor is generated from the pure silicon crystal. As we discussed before in the previous slide, pure silicon crystal only have 4 outermost valence. Therefore, in order to make it more stable, we need to have the process of doping. This process will be form a new structure and we call it as an N-type and P-type. Both structure is categorized as an extrinsic material, which is mean that they have modification to the original atom structure. The combination of N-type and P-type will produce a new combination of N-type and P-type will produce diode, or we call it as a semiconductor's electronic device. So now let's look more detail about how this process happen. At the first stage, the doping process will be conduct for the pure silicon crystal. This pure silicon crystal will alter by adding some specific impurity atoms, or we call it as a foreign atom for the atomic structure of the pure silicon. Either the foreign atom is the electron or hole, which is either proton or electron, then it will be generate the N-type P-type semiconductor. So why we need the doping process? So actually for the pure silicon crystal at the room temperature, some valence electron here have enough energy to jump to the conduction band. So it can cross over this band gap and jump to the conduction band. Once it jumps to the conduction band, we call it as a free electron. As a result, we have holes inside the valence band. This hole must be filled in by another electron that moves inside this valence band. This animation, this electron will be moved to next stage and it will move to the hole here. We'll fill in the hole, and when it have enough energy to jump to the conduction band, it will go to the conduction band and become as a free electron here. This free electron will carry the current flow to that electrical component. By that, it's able to be as a conductor. So if you look here, for the structure here, we can see that they have one hole here. So this hole must be filled in by another electron in order to make it stable. This process different between P-type and N-type. For the N-type, this silicon will be combined with another foreign atom which have the electron valence of 5, meaning that atom have 5 electron at the outermost shell. And when this foreign atom, it can be antimony, arsenic or phosphorus, when it combined with the silicon, it will produce N-type. As we know, in order to make it stable for the atom structure, so it must have 8 electron valence. So here for the silicon, they have a 4 electron at the outermost silicon, and this foreign atom, for example, we take the arsenic, they have 5 valence. So 4 plus 5 will become 9. We only want 8. So we have extra 1 electron inside this combination. So if you look here, they have 1 extra, which is it's free inside that atomic structure. So for the n-type material semiconductor, it will have extra electrons in the covalent bond. So this free will be moved to another structure which is need to be filled in for the hole. Now for the p-type of the semiconductor, we know that again silicon have 4 electron at the outermost layer, and for the foreign atom for the p-type we need 3 atoms. So here for the foreign atom, it can be boron, it can be gallium. So here when we calculate 4 plus 3, it will be produce 7 electron. So in order to make it stable, we must have 8 electron at the outermost shell. Now at this moment we are minus 1 electron. So if we look here, for the p-type, we have extra holes here, which is there's no electron in that hole. And this hole might be filled in by the extra electron from the n-type semiconductors. So when this hole is filled in by the electron from the n semiconductors and we combine it together, p-type and n-type, so electron that is extra at the n-type will move to the p-type. So this hole will be occupied by the n-type of electron. By that, our atom becomes stable. So as a summary, for the n-type material and p-type material, we can say that n-type material have the major carriers is an electron. So electron, if you look here at this image, electron is a major carrier and they have a lots of electron here, which is have a negative charge, and they have minority carriers, which is holes. So holes here meaning that this positive carrier. And for the p-type material, we can look here that the majority carrier is the holes, which is the positive charge, and the minority carrier is the electron, which is the negative charge. So the tips how to remember positive and negative. P. So P stands for positive. So keep it in mind that P is the positive charge and N is the negative charge. Okay, that's all for this subtopic. See you again for the next video.